So, hello, my name is Michelle, and I've been teaching math for many, multiple decades now. And today I'm just going to be talking about factor and quadratic expressions. And I've learned a lot through experience how to best approach this with students, but I will definitely offer a couple of different ways to do this so that you too can show your students the magic of mathematics. I want to start with the meaning of factor. Its original meaning comes from an agent of done or a doer. So in this context, though, it means one value of a product. So for example, factor times a factor equals a product. And that's, in this case, we're dealing with binomial factors most often. So that's just, again, something to keep in mind. So one of the things I like to do is talk about what students have already learned. They've seen multiplying pairs of numbers in third grade. They start to see factor pairs in fourth and fifth grade, especially when they get to fractions. Prime factorization in sixth grade, including the greatest common factor and lowest common multiple. And simplifying factors, terms, and expressions, middle school to high school. And then in early high school, they start to see binomials as factors. So one of the things that I also like to do is talk about factor pairs. And to me, this is one of the key ideas about factor and quadratic expressions. It isn't the quadratic so much that's the problem, but I really think that the idea here is to find a pair of factors, factor pairs, in which the learner must multiply and sum a pair of numbers simultaneously. So this concept map link shows some of the essential skills needed to factor quadratic expressions. The left side of this concept map represents some of the earlier foundational skills which progressively lead to more complex skills for this specific task. And again, I just spoke about those in the third through sixth grade middle school piece that I just showed you. So let's reintroduce some prior learning. All right, so again, we start with double distribution. And I know that some people call this binomial distribution, but I do like to call it double distribution because I want my kids to see that this is sort of a double process. So you have to take one pair of binomials, one binomial expression, and multiply it by another binomial expression. But I found kids really latch onto this idea of double distribution. So, and again, I usually familiarize them with something that they've already known. Now, this process does have another name known by the acronym FOIL. And yes, that's, maybe a good way to sort of remember the process or the procedure. But I really, really, really try to get kids to see this as a double distribution, that you're distributing these two terms with these two terms, multiplication over addition, which is what distribution is. So I usually start by taking 2x and plus 3 and writing them down. And then asking kids what they think ought to go in the parentheses. Now most of them will figure out that I've just separated 2x minus 3 and x plus 6. And again, I'm just reintroducing this idea. I would have already taught this to students before I started to factor quadratic expressions. But again, I'm just trying to remind them that this is something they know, and what I'm trying to do with factoring quadratic expressions is go backwards through this process, what I call anti-distribution. So it's really important to me to show them the forwards way, and so that then we can learn the backwards way. And again, I really connect this with the bigger picture of opposites in mathematics, so like plus and minus, multiplication and division, squaring and square rooting. I often this is one skill that we learned, or one operation that we learned backwards and forwards, and that are seen as counterparts to each other. So again, we have 2x times x, 2x times 6, plus 3 times x plus 3 times 6. So we get 2x squared plus 12x plus 3x plus 18. And then what I usually press upon them before I even add those two middle terms, which is what our next step would be, I really emphasize the fact that there are two middle terms here, and to be on the lookout for this, because we're going to return to this idea when we do anti-distribution or when we factor quadratic expressions. So again, I just really want to emphasize that. And again, we'll see those terms later. You can also do this using the four-square method here of 2x plus 3 and x plus 6. And again, you would get 2x squared and 18 and your two middle terms of 3x and 12x. All right, and again, either method works fine. Some teachers find this beneficial, some students as well, and students, I teach both so that kids can see it both ways. I want them to see this process, but I know that sometimes this is a little more straightforward way for them to look at it. So either way is fine with me. So, and then we're going to, of course, simplify that to get 2x plus 15x plus 18. And again, this is where we're going to start. And I tell the kids we're going to start here and we're going to work back to these binomial pairs. So again, these binomial factors. So we I really stress it at this point that we're going to start here and we're going to end here on the next problem. And in fact, I use this actual problem, so it's already familiar to them, to go in the other direction. So now let's go in the other direction. Let's start with 2x squared plus 15x plus 18. The first thing that we need to do is we need to label our A, B, and C. And again, this quadratic is in the standard format for quadratics. So, and again, we can teach that at another time. I'm just trying to teach, how to factor these binomials, how to factor these quadratic expressions into binomial factors. All right, so we're going to start there. We're going to identify them. And again, remember I said that the overall idea is that you're going to try to take a pair of factors, a factor pair, and you need to be able to, this is the key idea with this section, is that you need to be able to multiply them and add them at the same time, or sum them at the same time. All right, and I do remind kids that sometimes adding includes negatives, right? And again, we're trying to do that concept at the same time. So we're going to start by multiplying A times C. All right, so we're going to do A times C, which is, in this case, 36. And then we're going to look to see what factor pairs of 36 are going to sum to, where the sum is going to equal the middle term, is going to equal B. All right, and in this case, 15. Now I want to let you know that I'm writing this out, but I have this in a slideshow format so that you can follow along, or if you can't understand my sketchy writing, we can. So what I have found is that over time my students have begun to, they don't memorize their tables as often or with fluency as they used to. And so one of the things that I created for some of my students to make this idea more accessible to them was this factor pair chart. You'll notice that not all the factor pairs are here, and that's partly because I didn't include the prime numbers because they are easier to remember what their pairs are. And I will have this discussion with the students. In fact, I've even done activities with this factor pair chart, which again you can see. You can connect to the link in the slideshow if you want. And so what we're doing is we're looking at 36. All right, and we're looking for the factor pairs of 36 that are going to sum to 15. All right, and hopefully you can see that in here. Now, I know some teachers have students write all of the factor pairs out as possible, but again, I'm trying to get kids to really sort of hone in on what is the pair that they're looking for that's going to sum to 15 until they become a little fluent in what it actually means to multiply and sum a pair of numbers at the same time. So if you see this, it's 3 and 12. So that would be 3 plus 12 equals 15. All right, and so that means that I'm going to break this 15 up into two parts. I'm going to break it up into 3x and 12x. And it doesn't really matter which order you do it in, but that you do it. All right, and then you rewrite the rest of the equation. So 2x squared plus 18. And if you'll notice, again, what are those two middle terms? 3x, and I don't know why I wrote 6x, but 3x and 12x. And if you remember earlier, those were the same two pairs that we found when we did the inner and the outer terms of the binomial distribution. All right, and again, you can see that chart somewhere else. Now we're going to do something they've already learned how to do as well, and that's to factor by grouping. So I take this pair and this pair, and I find out what's most common, what they have in common the most. What is their greatest common factor? And in this case, it's just x. So I pull the x out and I factor out what's left. So 2x plus 3. And here I have a 6. They both have a 6 in common. So plus 6, and again, 2x plus 3. All right, and I do tell the kids to kind of check to make sure that, again, these are equivalent to each other, because, again, we're going to factor them out. And again, I point them back into, oh, we've moved up from this line here when we were doing double distribution to this line here. All right. And then the next part is, again, to factor each one of these. Now, they both have a 2x plus 3 in common, which I tend to write on the right side of the equation. And then what do they each have? After I factor out the 2x plus 3, I'm left with x plus 6. All right, and that is how we would factor a quadratic expression. So I also don't want to forget that you can do this the other way here as well. Once you've broken up the 15x into 3x plus 12, you can certainly put all those terms in the square. And again, the placement of those two middle numbers, those two middle terms, isn't really a big deal. And again, what do these both have in common? 2x squared and 12x have a 2x in common. And 3x and 18 both have a 3 in common, positive 3. And again, these both have an x, and these both have a positive 6. And again, here you go, you have your two binomial pairs, factors, so x plus 6 and 2x plus 3. So the last thing I want to show you is a lot of teachers like to start with this special case of when a equals 1 in ax squared plus bx plus c in the quadratic expression. Um, you know, I used to teach it that way, and I used to show kids the shortcut, but now I tend to teach it the other way so that they learn the procedure overall. Most of them will figure out the shortcut with these simpler problems. Um, I've just found that the scaffolding is a little more difficult to do if you just show them the special case of A equals 1, and then if you just show them the whole kit and caboodle. So I do want to put that out there, and I do want to show this as an example for those of you who will do this. One of the other things I haven't talked about too is what happens when you do have negatives in the expression. It's really no different than with the positives, because again, I think of positives and negatives as summing. But you do want to make sure that you have a product of -12, which means that one has to be positive and one has to be negative, and they have to sum to 4. So again, I pull out the chart with the kids. Again, most of them will start after using the chart for probably about a week. Most of them will ditch it because they will get what I'm asking them to do, or get what's being expected of them to do. So most kids will not need this chart. And again, I started doing this because I know a lot of kids did not know their timetables with fluency. And that was a very difficult thing for them to do. So again, one has to be negative and one has to be positive here. They have to sum to -4. So when I look at 12, I've got 1 and 12, which either sums to 13 or 11. And again, I talk about that with the kids. We also have 2 and 6, which sum to either 8 or 4, -4. And then again, we have 3 and 4. And so most of them will see that it's 2 and 6. And they will see that, sorry, I don't know why I did that, that the 6 has to be negative and the 2 has to be positive. So again, I will have them rewrite those two middle terms, positive 2x and -6x minus 12. And again, the procedure is exactly the same here. We're going to factor by grouping, and I will do the square in a minute. So again, these both have x in common, so I'm left with x plus 2. These both have a -6 in common, right? They're both negative, and 6 and 12 have a 6 in common, so they have -6 in common. And that leaves me with x and positive 2. And again, I take the factor that they share, x plus 2, and I write that on the right, and then I write the remaining pair on the left, so that I have x minus 6 and x plus 2. And again, you should have them check it. If you're going to do the square, again, you do need to make sure that you have your two middle terms. And again, there's no rhyme or reason to this. And it is what they both have in common. So these both have an x in common. These both have a -6 in common. These both have an x in common. And these both have a 2 in common. So that I have x plus 2 and x minus 6. So again, they can factor it either way to find the factor pairs, the binomial factor pairs that you need for factoring quadratic expressions. One final thing, please subscribe, hit the subscribe button. Please spread the word to other teachers. And I would love to hear from you as to what else you would like to see. I just started with this one because it seems to be fresh in my mind from this past teaching year. And I've done a lot with a factor pair table with my students. And I've just found again that it's just very, very helpful to them. And I really wanted to introduce that idea for those of you who haven't seen it and who are probably struggling just as I was with um, their lack of fluency with multiplying and dividing.